is chapter 9, problem 79, which is in the system shown a 12 kilogram mass is released from rest and falls, causing the uniform 10 kilogram cylinder of a diameter 30 centimeters to turn about a frictionless axle through its center. How far will the mass have to descend to give the cylinder 480 joules of kinetic energy? So we first find the radius, which is the radius of the cylinder, which is 15 centimeters or 0.15 meters. Our moment of inertia is equal to half mass times radius squared. And when we plug in the mass and the radius, we get that our inertia is 0.1125 kilograms meters per second. So now we find our kinetic energy, our rotational kinetic energy, which is equal to 1/2 inertia times angular velocity squared. And so we solve for our angular velocity, which is the square root of 2. It's the square root of 2 times our times 480, which is our kinetic energy, divided by our inertia, which is 0.1125, which gives us 93.37 radians per second. And then, so we come down here and we find our initial and our initial energy and our final energy, and we set the equations equal to each other. So our initial is mass times gravity times height, and our final energy is our kinetic rotational energy plus 1/2 mass times velocity squared. So we solve for h because our height, because we're trying to find how far it descends before we get 480 joules of energy. So solving for h gives us this chunk here, and then we plug in the numbers for kinetic rotational energy, 1/2 our mass, radius, our angular velocity, our mass, and our gravity. That gives us 13.87 meters, which is how far it will descend in order to get 480 joules of kinetic energy.